how a simple equation erased absolute time. For centuries, time felt unquestionable, flowing evenly forward, ticking the same for everyone, everywhere, without exception or ambiguity. It was the one constant humans trusted more than space, more than matter, more than motion itself. And in a single equation quietly proved that this shared clock had never existed at all. To understand how absolute time disappeared, we must have turned to an era when the universe felt orderly and synchronized. In classical physics, time was universal. Every observer agreed on what now meant. Events happened in a single, shared sequence. Clocks might run fast or slow due to mechanics, but time itself was assumed to be identical everywhere. This assumption was so deeply embedded that it was never questioned. It felt like common sense elevated to law. This view worked astonishingly well. Newton's equations treated time as a steady background, an invisible grid through which motion unfolded. Planets moved, objects collided, forces acted, and time advanced identically for all of them. Space could change, velocity could change, but time remained untouched. The problem appeared when light entered the story. Experiments showed that the speed of light did not behave like ordinary motion. No matter how fast the observer moved, light's speed remained the same. It did not add. It did not subtract. It refused to cooperate with classical rules. And this refusal created a contradiction no one could ignore. If time were truly absolute, speed should combine, motion should stack. Yet light ignored that logic completely. Something had to give. Either experiments were wrong, or time itself was not what physics believed it to be. The solution did not come from new instruments. It came from a re-examination of assumptions. What if space and time were not separate? What if they adjusted to preserve light speed? What if time itself was flexible? A simple set of equations answered yes. Lengths could contract, time could dilate, simultaneity could break. Events that appeared simultaneous to one observer would not be simultaneous to another. The universe did not share a single clock. This was not a technical correction. It was a conceptual collapse. Absolute time did not survive contact with reality. It dissolved into something dependent on motion, position, and observation. And once this was accepted, every idea built on universal now began to unravel, pulling physics into a reality where time itself was no longer fixed, but negotiated by the structure of the universe. Once absolute time was questioned, the universe began to feel deeply unfamiliar because the idea that everyone shared the same present moment had been quietly holding reality together in the human mind. When that idea collapsed, it took intuition with it. Time was no longer a universal background. It became something personal, relative, and dependent on motion in ways no one had ever imagined. The equations showed that clocks do not simply tick at different rates because of mechanical flaws or environmental conditions. They tick differently because time itself flows differently for observers moving relative to one another. The faster you move through space, the slower you move through time. This was not metaphor. It was measurement. Clocks in motion genuinely recorded fewer seconds than clocks at rest. This meant simultaneity was no longer absolute. Two events that appear to happen at the same time for one observer could occur in a different order for another. There was no universal now slicing across the universe. Each observer carried their own version of the present, shaped by their motion and position. Time fractured into perspectives. At first, this sounded philosophical, but experiments made it physical. Atomic clocks placed on fast airplanes ticked more slowly than those left on the ground. Satellites orbiting Earth aged differently than receivers below. GPS systems required relativistic corrections to function at all. Without accounting for flexible time, modern navigation would fail within minutes. Space also lost its rigidity. Lengths contracted in the direction of motion. Distances depended on who was measuring them. Space and time stopped being separate entities. They fused into Spacetime, a unified structure where changes in one demanded changes in the other. Reality adjusted itself to preserve consistency. The simple equation that erased absolute time did not remove order. It replaced one kind of order with another. Causality survived. Light remained the ultimate speed limit, but the universe abandoned the idea of a shared clock entirely. Agreement gave way to coherence. This new picture was not optional. It applied everywhere, from particles and accelerators to stars orbiting galaxies. Time dilation was not a quirk. It was a rule. Motion reshaped duration as reliably as gravity reshaped geometry. What made this unsettling was how invisible it felt. At everyday speeds, differences were too small to notice. Human experience hid the truth, but precision exposed it. Reality had been lying politely all along. Once time lost its absoluteness, the universe became a web of perspectives rather than a single timeline. Events no longer lined up neatly. They depended on paths taken through space-time. History itself became observer-dependent in subtle ways, and with that realization, a deeper tension emerged. If time could stretch and compress depending on motion, then it might also respond to other influences. Motion had broken time's universality. Gravity was about to finish the job. The conflict reached its full intensity when gravity entered the picture, because motion alone had already fractured time, but gravity threatened to bend it beyond recognition. If speed could slow clocks, then mass might do the same. And once that possibility was taken seriously, time could no longer be treated as a passive dimension. It became dynamic. Einstein's equations revealed something deeply counterintuitive. Time does not flow uniformly through space. It flows differently depending on how close you are to mass. The stronger the gravitational field, the slower time passes. Clocks near massive objects tick more slowly than clocks farther away, not because they malfunction, but because time itself is stretched. This effect is not subtle in principle. Near black holes, time slows dramatically. From a distant observer's perspective, objects appear to freeze at the event horizon. Moments stretch endlessly. The future piles up without arriving. Gravity does not pull time. It warps it. This shattered the last refuge of absolute time. Not only did observers disagree based on motion, they also disagreed based on position. Two identical clocks, perfectly synchronized, would drift apart simply by existing at different heights in a gravitational field. Time was local, contextual, shaped by the universe's geometry. The implications were staggering. There was no master clock governing reality, no universal rhythm. The universe did not advance as a synchronized whole. It evolved as a patchwork of timelines, each flowing according to local conditions. This meant aging itself became relative. Astronauts aged slightly slower than people on Earth. Satellites experienced time differently than receivers below. Even your feet age more slowly than your head by a tiny amount, because they sit deeper in Earth's gravitational field. Time is uneven everywhere. The equations did not allow exceptions. Every process that depended on time was affected. Chemical reactions, biological aging, radioactive decay. Nothing escaped. Time was woven into matter itself. This destroyed the idea of a global present completely. There was no universal now slicing across space-time. There were only local moments connected by light signals. Reality did not update everywhere at once. It updated relationally. What made this conflict unbearable for intuition was that nothing appeared different. Life continued normally. Clocks still ticked. Aging still felt steady. Yet, beneath experience, time was fragmented, flowing at different rates in different places. Physics had revealed a universe where time was not a backdrop. It was an actor, a variable shaped by motion and mass. And once that was accepted, the question was no longer whether absolute time existed, but whether time itself was fundamental at all. The climax of this story is not a dramatic explosion or a sudden revelation, but quiet realization that reshapes everything we thought we understood about existence itself. Absolute time was never taken from us. It was something we invented because reality felt simple at human scales. Once physics looked deeper, that invention could no longer survive. Time did not disappear. It transformed. It became something that flows differently for different observers, something that stretches and compresses depending on motion, mass, and position within the universe. What felt universal was revealed to be local. What felt constant was revealed to be conditional. Time was no longer a background. It was part of the structure of reality. This explains why the universe remains consistent despite fractured timelines. Causality is preserved because signals are limited by light. Order survives because space-time enforces coherence. There is no chaos, only context. Each observer carries their own clock, yet all clocks fit together into a single, self-consistent geometry. The loss of absolute time did not make the universe unpredictable. It made it more precise. Events are not ordered by a cosmic schedule. They are ordered by relationships, by who can influence whom, by which signals can arrive. Reality is stitched together by interaction, not by a shared present. This reframing changes how we think about past and future. The past is not a fixed slice shared by all observers. The future is not a single destination. Different paths through space-time experience different durations, different sequences, different versions of now. Time becomes something you travel through uniquely, not something you receive equally. Yet this strange universe works flawlessly. Satellites navigate, particles collide, stars evolve. Despite the loss of a universal clock, consistency emerges everywhere, not because time is absolute, but because the laws governing it are. The simple equation that erased absolute time did not weaken reality. It revealed its deeper order. A universe not synchronized, but coherent, not uniform, but relational, not ruled by a single ticking clock, but by a structure that allows many clocks to coexist without contradiction. Once this is understood, time no longer feels like a mystery to be feared. It becomes a feature to be respected, a reminder that perspective matters, that motion matters, that position matters, and that reality is richer than intuition ever suggested. So, what do you think? Are we still living as if time belongs to everyone equally? How